Have you ever wondered how a rough, dusty, uneven surface suddenly turns into a perfectly blended and smooth road base within minutes without any big rotating mixer or complicated plant on site? At first glance, it looks like a motor grader is simply pushing soil forward, but the reality is far more technical and far more interesting because the true secret lies in blade geometry, material behavior, and operator precision. When granular material such as crushed aggregate is dumped over prepared soil, the process does not begin with random movement. It starts with controlled layer thickness, because if the layer is too thick, uniform blending becomes impossible, and if it is too thin, structural strength may not meet design requirements. The motor grader's moldboard, commonly called the blade, is the heart of this operation, and it can rotate, tilt, side shift, and adjust vertically through hydraulic control, allowing the operator to set a precise angle, usually between 25 to 45 degrees. So instead of pushing material straight ahead, the blade forces the soil and aggregate to roll sideways along its curved surface. This rolling action is the hidden science behind the mixing process, because as the material continuously tumbles and folds over itself, fine particles fill the voids between coarse aggregates, improving interlocking and gradation uniformity. During the first pass, the grader cuts into both the soil and the granular layer simultaneously, initiating blending while forming a windrow, a ridge of partially mixed material collected along one side of the blade. This windrow is not waste material. It is part of a controlled mixing strategy. On the second and third passes, the operator recuts this windrow, rolling it back across the surface from opposite directions, ensuring cross-mixing and eliminating unmixed pockets. Normally, at least 3 to 4 passes are required to achieve consistent blending, depending on moisture condition and layer thickness. Moisture content plays a critical engineering role in this transformation, because if the soil is too dry, particles will not bond effectively during compaction, and if it is too wet, the mixture may clump and lose uniformity. The ideal condition is near optimum moisture content, where maximum dry density can later be achieved during compaction. And this is why experienced engineers always assess moisture before final grading. As the mixing becomes uniform, the blade is adjusted for final leveling, maintaining the required camber or cross slope to ensure proper drainage performance. This stage is not just about smooth appearance, it directly affects structural behavior, because uneven blending can lead to weak zones, differential settlement, rutting, and early pavement cracking under traffic loads. A properly mixed material distributes loads more evenly, increases shear strength, improves compaction efficiency, and ultimately extends pavement life while reducing maintenance costs. What looks like a simple grading operation is actually a carefully controlled engineering process involving blade angle control, rolling mechanics, cross-pass blending, moisture optimization, and thickness management. So the next time you see a motor grader working on site, I'd remember that it is not just smoothing the ground, it is scientifically transforming separate materials into a strong, load-bearing foundation through precision, physics, and professional skill.